Okay, so this will be the overview for today. So first I will introduce you to Kubernetes, and then I will tell why we need Kubernetes and what it can do, and then main components in a Kubernetes cluster, and the main architecture of a Kubernetes cluster, and some configuration files we needed for Kubernetes cluster, and finally a demo. So if time permits, I will go through Helm and Helm charts as well. Okay, so first, what is Kubernetes? So as you can see, Kubernetes is an open source orchestration framework for deploying, managing, and scaling containers. So we use this Kubernetes framework to manage containers. So it can be hundreds or it can be thousands, and those containers can be hosted on virtual machines or in cloud. So through this framework, it allows us to easily manage those containers. And in future slides, I will explain how these Kubernetes help us in deploying, managing, and scaling these containers. Okay. So, the one thing I forgot to mention at the start is also like this was introduced by Google and managed by Google. And so why this Kubernetes thing came into world? Because the current world is like moving more and more towards the microservices. So like because the bounded context within the microservices, the limiting communication with other microservices, the containers is the main like the best suitable way to deploy those microservices. So the increase of those microservices and these containerization technologies emerges a need for an framework to manage all those containers within a program. So that's how these Kubernetes emerge. So what it do? So these are the main functionalities provided by an Kubernetes cluster. So it provides service discovery and load balancing. That means like a container within a Kubernetes cluster can expose through a DNS or a public IP. So the people through a browser, people can access those websites hosted on Kubernetes cluster. And the other thing is the load balancing. So if the network traffic is high to an Kubernetes cluster, it has the ability to like balance the network either by creating new containers or like managing the resources it has given. And the another feature is like storage orchestration. Storage orchestration means like with this Kubernetes cluster, we have the luxury to mount a volume, mount an storage. So this storage either can be a local storage or it can be a cloud storage. Other thing is automated rollouts and rollbacks. So for this Kubernetes cluster, we can define a desired state, like these are the this much of containers need to be run, and these are the resources we are going to allocate. And then this cluster has its ability to compare the actual state, because the containers can die easily. So this Kubernetes has the ability to compare the desired state and the control state, and then create containers if needed, and like to free the resources if those resources are not being used. So it has this feature, and automatic bin packing as well. So we can create containers like we can tell to the Kubernetes cluster, these are the resources we are going to allow, like this much of RAM we are going to allow, and this much of processing power we are going to allow. And this Kubernetes is intelligent enough to make use of those resources efficiently. And then it has the self-healing power as well. So if a container dies, so it has the ability to restart a container. And also uh, other thing is like so this Kubernetes cluster do a health check of their containers itself. So if those containers are not fit into the health check, so this Kubernetes cluster itself uh, destroy those containers and create new ones. And the other thing is like the secret and configuration management. That means like we can store configuration data like database connection strings and all without embedding them in the application code itself. We can store them on a separate store. And also they have another store called secret to store secrets, confidential store. So we can store the usernames, passwords, then the tokens and the SSH keys. All those things can be stored safely. So test those features. Now let's see the main components which we can see within an Kubernetes cluster. Okay, so the first component which I'm going to talk about is the node. So node is the place which provide you the luxury to deploy your containers into a pod and then deploy into a node. And so this node can be an physical machine or a virtual machine. It can depend upon your choice. And also in a Kubernetes cluster, there are like multiple nodes communicating to each other. And ideal scenario, so there should be like two nodes, a master node and a worker node. So the master node manages other worker nodes, but all those master node processes and worker processes can be run in a single node as well. Yeah, so then the next item, then the most important the component is called a pod. So pod is the most it's the smallest deployable unit in an Kubernetes cluster. So it is the place where we deploy our containers into. So the recommended way is to only deploy one container into a single pod. And like these pods does not maintain a state, so they can die easily and another pod can be created instead of it. Yeah, so that's about pods. Yeah, so there can be multiple pods placed within a single node. And the other thing is, yeah, so the next thing is like when you deploy pods into a Kubernetes cluster, so it creates an private virtual network among itself, so giving private IPs to itself. So that's how they communicate. But as I mentioned earlier, these pods can be destroyed easily. Then there's an issue like when a new pod gets created, a new private IP is allocated, then the other pods can't communicate with, with the newly created pod. So to mitigate that, they have another feature called service. So what service does is like it's like an abstract way to expose a Kubernetes cluster as a network service to an outside. So like it's another separate service attached to a pod. So this life cycle of this pod does not depend upon the life cycle of this service, and these services are given permanent IP addresses. And so if although a pod dies, this service does not get die. So a pod can be destroyed, another pod can be recreated to instead of this pod, but it can use the same service which is allocated for that set of pods. Yeah, so that's the way how these pods gonna communicate within a Kubernetes cluster. And then another component I'm going to talk about is called the ingress. So ingress is the component which allow us to communicate HTTP and HTTP routes inside to a cluster. So that's where it's open to an outside world, so we can access through a browser. Yeah, so these are few others. Then the other component which I'm going to talk about is called configuration map. So configuration map is a key value data store, which is mainly to store configuration data. So the recommended way is to like store configuration data such as like database strings and all those kind of things into this configuration map. So and it should not exceed 1 MB. So the main purpose behind this configuration map is to like the separate configuration data from your application code, because like if you use this configuration data within the application code itself. Like if there's any configuration change, then you need to redeploy, and like there are a lot of process happening, like a lot of time wasted and resources being used. So if you separate this configuration data from an application code, so you can easily change and manipulate those things. And then it has another feature called secret. So in secret, what we mainly store is the credential information, such as like a database username, password, a token, a key. So those kind of credential information is stored in a secret, and like all those things are stored in a key value pair manner. So yeah, that's about secrets. Okay, so the next one which I'm going to talk about is called volume. As I mentioned earlier, so this is an database pod, but as I mentioned earlier, so they don't keep the state. So these pods can be destroyed easily. So if you store a database within a pod like this, uh, then the data which we have stored will be lost. So to mitigate that kind of a thing, so this Kubernetes allow us the facility to mount our data, like mount a local storage within a node as a database, or we can mount an cloud database to a database server, so that although the pod dies, the data won't die, which provide the luxury to persist the data. Yes. Okay, so now we will see in a practical scenario how this thing gonna behave. So this is an example of a single node with two pods. Think for a moment, this is an pod which has hosted a front-end framework, front-end application such as Node.js, and then in this pod we have deployed a backend application such as like ASP.NET Core or anything like that. And then two services are defined for that, and they are communicating each other through the services. Now if a pod dies, if a front end pod dies, then we have a issue, because like there's no application to contact through the browser. Then our site will be down for a moment. So to mitigate those kind of things, so basically what we do is like we create replica sets. So normally we create multiple pods of this with the same image, which connect to the same service. So in this kind of architecture, what it does is like, so if a pod dies, so it has the ability to contact the other pod which it has connected through the service. So this guarantees us the 100% availability of our system. And the other thing is like in practical world, so we normally don't deal with pods itself. So there are few wrappers which we have provided us by Kubernetes to manage these pods. So that component is called the deployments. So through deployments, we specify this is the image we are going to deploy, and we need this kind of pods of this image, and like how like the resources which we are going to allow for this pod. So all these things are managed through a deployment. So all the pods and the services, all the things are managed through these deployments and these configuration files, which I'm going to talk next. Okay, so then about the architecture. So this is the main architecture of an Kubernetes cluster. So there's an hello.
Can hear you.
Yeah. Okay. Okay. So there are two main components, as I mentioned earlier. There are worker nodes, and then there's one called master node. So first I'll explain the processes run on worker nodes. So there are mainly two processes run on each node. So first component is called kubelet. So kubelet is responsible for the pods deployed within the node itself. So it maintains the life cycle of those pods, like create new pods if they get die, and all those like, status management things will be done through this kubelet application. And then there's another one called kubeproxy. So through kubeproxy is like a network proxy, so it helps like the service which I mentioned earlier to load balance the requests which it receives, like those kind of things are done through this kubeproxy. And then when you can talk about this master node, the first thing which is more important is this called API service. So this is an entry point for an Kubernetes cluster. So it's an default gateway, and it also provides the authentication. And so all the authenticated requests only flow through so this is the main entry point for an Kubernetes cluster. So we can install the authentication information to this, so only the authenticated request will flow through to the other nodes of the cluster. And then another component called scheduler. So scheduler is responsible in creating new pods and allocating resources and all. So first, if a request comes to create a new pod, so it will transfer that message to scheduler. Then what does scheduler do is like it will first like identify the resources used by the current nodes, and then it will create a pod in a node in which the resources are used in minimum. And then we have another component called etcd. So this is an actual and database. So all the information regarding the Kubernetes cluster will be written onto this database. So it will store those data in a key value pair. So like data like the current status of the cluster, like how many pods are running and how many the CPU usage of the nodes, and all those like information will be written into it. So the other processors will compare the current state and the desired state and create new pods if necessary using this database. And then another feature called controller manager. So this controller manager is responsible in controlling the request it receives, like it like manages the resources allocated to it, and all those things will be done through this control manager. And then there's another control manager for like to manage the cloud infrastructure communication with other cloud infrastructures as well. Yeah, so that's about the main architecture. Now I'll talk about some configuration files which we used in developing this Kubernetes cluster. So on the left side I have shown is an deployment configuration file. So its kind is deployment, and on the right is an configuration file for deploy and service. Uh, yeah, so okay, then the next section in a configuration file of this kind is called metadata. So this metadata contains information about like labels and some timestamps and all. So these labels are used to identify in identification process. For example, now see this the label name of this is called Angular Web App, and so in here in the service it's used as the selector. So to identify, to match between these deployments, to now in this case these services belong to deploy this deployment. So to match these services and deployment, we use these labels to attach to the correct service or the deployment. And then about the next section is called the specifications. So on the left side I mentioned it's an deployment type. So in there the like according to the kind the specification details differ. So this deployment type configuration type has like it mentions like to create two replicas, that means to create two pods. And then if you go down, you can see it has mentioned about an image. So use this image as the base for the pod, and then the name of the pod and the port which it's accepting outside connections. So according to this deployment file, so this will create two pods with this image reside in each pod, and it will listen connections through this connection port. And then this is the service file of that created two ports. So this one will listen on port 3040. So and all the connections received for this port 3040 will be forwarded to this pod through this container port. So that's how the matching part happens between these pods and services. And another special thing about this service is we specify a type. So if we specify the type as a load balancer, so this acts as an external service in which it allows, like, this will get an external IP. So I'll show it in the demo as well, like how we get these things and how we can communicate to these using those generated IP addresses and all. And then there's another section called status information. So these status information are generated once we deployed these files into a Kubernetes cluster. So what it does is, like, it monitors the current status and write to uh, the current status of the web pod to this file. So this is the one which uses to compare the desired state and the actual state. So this is the actual state, and this the replicas mentioned over here is the desired state. So they compare those two and create pods if necessary, and release resources if they are, like, not used within the cluster. So those are the main things regarding the configuration file. Yeah, so then there's for this local development, there's a tool called Minikube. So it provides us an single node Kubernetes cluster, and since it's a single node, all the master processors and the worker processors will run on that single node, and it will run on a virtual box. And then the command kubectl. So this is the command line interface which we use to interact with an Kubernetes cluster. So we give commands using this interface, command line interface, so that the Kubernetes cluster receives and performs them. Yeah, okay, so let's move on to the first demo. Yeah, so in the first demo, what I'm gonna show you is, like, I will deploy two pods. One and Mongo, one pod will be an Mongo Express pod. So this what Mongo Express does is it's an web interface to connect to an MongoDB database, and the other pod will be MongoDB database. So there's this UI component, and this, consider this as an UI component, this as an backend component. And then I will create a config map. So this config map will hold the connection string, like the database location service of this database. And then I will create a secret. So secret will contain information like the username and password of this MongoDB database. And then I will create two services, so in which these services will attach to these ports, and they will interact and give us an output. And I will declare this service, the service with attached to the Mongo Express, as an external service, so that outside world can access it through an browser. So okay, let me unshare. Can you see the screen?
Yes, Roman.
Okay, so okay.
You can see the presentation.
Yeah, okay.
Presentation screen.
Cool. First, I will show you. So I'm not gonna use Minikube at all because like in one go, gonna use the Azure resources and show you how to work in Azure so that within single demo I can demonstrate the Azure features and all. So in here I have already created a resource group called Tech Talk Demo Resource, and then I have created a cluster called Tech Talk Demo Cluster, and there's another registry as well. I'll explain it in my next demo. So if you go to an Tech Talk Demo Cluster, so this is an overview of it. So I created this. I've enabled only a single node for this Kubernetes cluster. So let's like try to go and create a new one so you can see the specifications which we receive creating cluster. So first you have to select the subscription and then the resource group, and then you can select a name for your Kubernetes cluster and then a region, and then you can select a Kubernetes version which is going to use for this cluster, and then in here is the place where you can decide the number of nodes which you are going to use for this cluster. And then the other important thing is like, so you can enable role-based access control for this cluster while you're creating it, and then you can create a private traffic routing and all those things as well. So since I've already created a new cluster, I won't create a cluster at this moment. I just use this this cluster which I have already created. Okay, so I'll just okay, I think you can now see VS Code screen, right?
Yes, yeah, we can see.
Yes.
Yeah, okay, cool. Yeah, so first I'm gonna create a secret which I mentioned earlier. So what this gonna store is the username and password for an the MongoDB database. Okay, so first, so the luxury which we have with this kubectl is like we can connect to an Azure uh, cluster from your Azure CLI and then work on it. So okay, so what this does is like this. So this is the tech demo cluster is the cluster name which I've created, and this tech talk demo resource is the resource group which it resides on. So what will this do is like this will create to the cluster which I have created. Okay, so now I have created the cluster. So with kubectl I can do various modifications to the cluster because it has now connected to the cluster in the Azure. So I'll run few commands like kubectl get nodes. So this will display all the nodes. So this node is being built by Azure itself, and then you can run kubectl get services to see are there any services deployed or not. So this is also an inbuilt one when you create a new cluster, and then kubectl get config maps and all. So these are the default ones created when you create a new cluster. So as the first step, I'm gonna deploy this mongo secret.yaml into our Kubernetes cluster. So the steps to do is you can clearly call Kubernetes kubectl create -f, and then you can specify the file name. So these files are in YAML format, And if I run this command, okay, so now this secret is created in that cluster. Let's see ctl.get secrets. Okay, so now you can see MongoDB secret is being deployed. Now we'll deploy a config map. So as I mentioned earlier, config map will hold the connection information to that database. So in here, the database URL we are going to use MongoDB service. So if you go to, so you can see in service it has defined as Mongo service. So that's the URL we are going to use. And so hello.
Yeah, we can hear you now.
Hello.
Okay, so I now run this. Okay, so now this config map is also deployed. Let's see.
Ravidu, we can't see your screen there.
Oh, sorry. Okay, can you see it now?
Yeah.
Okay, so I have deployed the config maps, and then okay, so this is the deployment for that MongoDB. So in here, which I have mentioned the name label as MongoDB and replicas as one. So this will create a single pod, and like the other important information is, and as the image I have mentioned in here as Mongo. So what this Kubernetes cluster will do is like it will retrieve the image from the Docker hub in this instance. So it will retrieve the image and deploy it into this pod, and the name which I have given is MongoDB, and the container port. So the port which opens to this port is 27017, and then there are some configurations which I mentioned about the root username. So root username, we are going to take it from the secret file which we have deployed earlier. And so the root username and the use password, all these two information will be fetched from the secret which we have deployed earlier. And so in YAML files we can deploy two files by separating using three dashes like this. So then this behave like two YAML files. So this will be the service of this MongoDB. So the kind is specified as service, and this selector is MongoDB, and in here we have specified our label as MongoDB. So this is the service. Yeah.
So can we just have only one secret file? So it will only refer to one place. Is that so, or is it possible to have multiple secret files as well?
You can have any number of secret files, but it's like the recommended way is to keep those things in a single file. And if
in that case, don't we need to also specify what the file is, or will it like have a single
yeah,
key value?
that's okay here. Now in here, so in here we have specified the metadata called MongoDB secret, and in here you can see the same name has been used. That's how it matches this the place where we need to fetch the file.
Okay. All right. Okay.
And also this key is Mongo root username, and in here secret. So this Mongo root username is being used, so then this value will be used. That's how it matches the key value pairs which we have mentioned here. Yeah, so then the other part is the target. So one important thing is like in here this container port and this target port should match, because this is the place where the connection opens between the pod and the service, and then we specify another port called port this to allow incoming connection. So when it receives incoming connections through this port, then it will forward all those the messages to this port using this port, this 27017 port of this port. So that's how the connection happens. So I'll deploy this file as well. Okay, so it says that the deployment is created and this service is also created. We'll see kubectl pods. Yeah, so you can see MongoDB deployment is running. So it's still not ready, still creating the container. So if we run again, okay, now you can see it's running, and also you can see the kubectl get services. You can see the service which we have run. Okay, so if I go back to my diagram, if I go, you can see the presentation, right? I hope so.
Yeah,
So
yeah,
now,
we can.
yeah, okay, so now I have deployed the secret, the configuration manager, and this MongoDB pod, and then this service. So the two things which we have left, or we with this Mongo Express pod and this service which allows external communication and also passes data to the internal pods, internal services as well. So now we'll create that. So this is the deployment file for that deployment. So the name is label is Mongo Express, and then we specify to create one pod, and then the container pod, and then we have specified the username, admin username and password. So we ask them to fetch it from the secret file which we have deployed earlier, and username and password fetch it from that secret file, and this MongoDB server location, so we are asking to fetch it from that config map which we have deployed earlier, and then this is the service of it. Yeah, so one another thing which important thing is this type load balancer. So if you specify the type as load balancer, it will allow external communications, and it will give an public IP to access this pod. Yeah, so you can see this container port and the target port matches, and this is the port which it receives incoming connections. Yeah, so I will deploy this thing as well. Okay, so this service and the pods has been created. Now we will see kubectl get services. Okay, so now you can see this express service. It's of type load balancer, and I think you can see the console, right? Is it large enough, or do I need to increase the font?
If possible, it will be better if you can zoom in a bit.
Yeah, better.
Okay, so you can see these are the internal, like the private IP is within the cluster, and you can see for this service the external IP is pending. So if we run that command again, it might have, yeah. So now it has get the public IP. So now we'll check using this IP whether we can access this database, this Mongo Express website. This is the port, and then the node is 8081. Okay, so it's working. Now we'll try to create a request so that it will goes to the MongoDB and come back with a result. We'll create a database. Right. Okay, so it's working. That's why it's being listed over here. Yeah, so that's about that. So if I so these are the components which I built. So what happens is, like, when you create a request, it will received by this external service which we created with this Mongo Express service, and then it will reach the pod, and then the request is transferred to the service of this MongoDB, and then it will return a result, and it will be displayed on the browser. Yeah, so that's the first demo. Now the second one, which I'm gonna show you, like an real scenario which we might encounter, like the things. I'm gonna deploy an actual like project on Kubernetes cluster. So in here I have already created an node project, Angular project with a node backend. So since I'm using Linux, I just went to a lightweight backend Node.js, and so what I'm gonna do is, like, I'm gonna host this on a Kubernetes cluster and access through an IP address. Yeah, so I've included an Docker file for this thing. So what it basically do is, like, fetch creates a Docker image. So first we'll create the Docker image of this application. So first we'll see there whether I have already created it. Okay, we haven't already created it, so I'll just create it. Yeah, so this will build the Docker image and put it into the Docker images. Yeah, so this will take some time. So since this thing goes on, I will be explain about the other thing which I needed to show you. So I mentioned about an registry. So this is the place the container registry. Azure Container Registry is the place where you can store Docker images. So for an Kubernetes cluster, you can either define to pull the image from a private container registry, like the one which I have already created, or as in the MongoDB example, you can specify it to, like, pull the image from the Docker hub. So it's intelligent enough to identify and pull the image. Okay, so let's see. Okay, it's still building. Okay, now it has built. Let's see the Docker images. Okay, you can see that under the Docker images with tag v1, it's already there. So so, like, to push an image to an Azure Container Registry, so Azure guys has recommended it to tag it with this yeah, so we need to tag the Docker image with this their login server. So they mentioned that it's easy for their routing facilities. So we need to tag with this tag our image with this prefix. So I'll just tag it. Okay, now if we see the Docker images, now you can see the same image with the tag which we have specified. Okay, so now what we'll do is like we'll log into the this we'll log into this tech talk demo registry container registry, so then we can deploy our image to this thing. Connecting, we'll just take the command. Okay, so we have succeeded registering that. Now what is the same code, because I have created one also tech talk demo registry. Yeah, that's fine. Okay, now what we'll do is we'll push the image to the container registry. Okay, so the name should be okay. So now what it will do is like the local image will be pushed into the Azure container registry. So this will take some time, like 2 to 3 minutes. So while this thing push to that container registry, I'll go through one another thing which is so this is another thing associated with this Kubernetes web. I hope you guys can see the screen. Yeah, so it's called Helm. So Helm is like an package manager for an Kubernetes cluster. So this acts as an like the apt library in Linux and brew library in Mac. So this is an package manager. So this package manager, what it holds is an collection of the YAML configuration files, because like for an instance think like in deploying that Mongo Express pod as well, so the steps we need to follow is the same, only the configuration values differ. So the people have identified that, and like they have created repositories to with the collection of those configuration files. So the collection of those configuration files is called the Helm charts. So to deploy easily, to like to deploy into the entry environment separately for, and one another feature major feature which they provide is like the templating engine. So we can specify the keys as it is, and as values we can uh, specify what do you call like variables. So at in the CI/CD pipeline you can define a values file for separately for an dev environment, then for an staging environment, and then for an production environment. So during the CI/CD, the values will be fetched, and those values will be populated in those configuration files, then it would be really easy for us to deploy, do the deployments to an Kubernetes cluster. Yeah, so those are that's an overview of the Helm and Helm charts and the main use case of those Helm charts. So now let's see whether that thing has pushed. Oh, not yet. So we'll wait for another 2 to 3 minutes. So if you have questions so far, you can ask while this thing is being pushed to that container registry.
Ravidu, rather than using a separate Docker registry in Azure, can we use the Docker registry as well, like the one where the Docker is maintaining?
You mean the Docker Hub, right?
Yes.
Yeah, so in the first example, the MongoDB and the Mongo Express example, so it uses the images from the Docker Hub.
Okay. For the custom images, you are using this one, right?
Yeah,
For the custom content. Yeah,
like, so in our environment, what we do is like we mainly develop our system and we don't need to host it in the Kubernetes environment. So we need to create a custom image of our one and then need to do these steps.
Yeah, okay.
Ravidu, one question for the deployments. Now, say if you want to if you are using CI/CD pipeline for the deployments, now is it like now this Kubernetes is a sort of a container management register manager, right? So how does that contribute? Is it because Kubernetes is the one which manages nodes, pods? So what's the relationship between the C release pipeline and Kubernetes? Because the Kubernetes does this dynamically at runtime, isn't it? The CD is sort of a one-time deployment.
Yeah. Actually about that, so I don't have a clear answer for that thing because like I haven't worked with CI/CD with this Kubernetes thing.
Okay. All right. That's okay. Thanks.
Okay. So now I have pushed that container into the container registry. Now what we will do is that we'll attach that container registry to use with the container Kubernetes cluster which I have created. So the command to do that is update, then the cluster name with the resource group, and then the the container registry. So then it will attach the container registry with the the Kubernetes cluster. Okay, this thing is still running. Okay, this is still running. Okay, so now it has attached to the Kubernetes cluster. Now the final step. Now what we're gonna do is to run this Kubernetes YAML file. So this is the deployment file for that for this web app. So I'm mentioning here to create 2 replicas, and then as the image I'm talking, I'm asking to use the one which we have deployed just now, and the other things are the basics thing which I have explained earlier. Now if I run this command, apply minus Kubernetes YAML. Okay, so it has created the web app. Now we'll see kubectl get services. Okay, so there's this Angular web app which we have deployed, so it's saying that it's pending. Let's try again and see. Okay, now it has got an external IP. Now what we do is we'll try to go. What was the port? Port is 3080. Okay, it's working. So I've just created the simple one. So what it does is like it will store these on a not a persistent data on the memory, and just adds these things on hand. So this thing is working. Yeah, so those were the things which I needed to show you. So these were resources which I've used in creating this presentation. Okay, so do you have any questions?